Welcome to our first video in the series of fractions, where we'll be looking at the basics of fractions, such as to understand how different diagrams can represent fractional amounts, and also how to find equivalent fractions as well. So our learning objectives are to recognize and represent simple/proper fractions, to find a fraction of a whole amount, i.e., for example, let's say you had a question asking you to find 2/3 of 24. So basically how to find fractions of whole amounts, and to understand how to find equivalent fractions. So we'll start off by looking at what is a simple fraction. Well, it is in the name. A simple fraction is a representation of a whole amount. So we're being given a diagram here to look at. So we can see there are 1, 2, 3, 4, 5 shaded parts all together. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts all together. So if we wanted to represent this diagram, if you ask me what fraction of the diagram is shaded, well, I would say it's 5/10 or 5/10. And why? Well, if we look at how many parts are shaded, we said there was 1, 2, 3, 4, 5. And the 5 tells us how many parts are shaded, or how many parts of the whole we have. And this number is called our numerator. So there are 1, 2, 3, 4, 5 parts of the whole being 10, which is shaded, which is why 5 is our numerator. Now the 10 in this case is our denominator, which tells us how many parts make up the whole. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts of the whole together. Now we call this 10 our denominator. So the numerator is the number that tells us how many parts of the whole are shaded, which is, again in this case, 5. And the 10 is the number which represents how many parts of the whole, how many parts make up the whole, which is 10. So 10 is our denominator. So let's have a go with some few examples. So what fractions are represented in each shaded diagram? So we've got 2 examples here. We've got one diagram here and another diagram here. So let's have a look at the first one. And so if we remember from the last slide, our numerator was the number which represented how many parts of the whole are shaded. So if we look at this first diagram, there are 1, 2, 3. So our numerator is 3. And how many parts make up the whole together? There are 1, 2, 3, 4, 5, 6, which makes our denominator 6. So the fraction for this diagram is 3/6, or 3/6. 1, 2, 3. 3 is our numerator. 1, 2, 3, 4, 5, 6. 6 is our denominator. In our second diagram, how many parts are shaded? So there are 1, 2, 3, which is our numerator, and how many parts make up the complete whole? 1, 2, 3, 4, 5, 6, 7, 8. So the fraction to represent this diagram is 3/8, or 3/8. So now we've understood how to represent fractions and understanding what simple fractions are, we can use this to find fractions of whole amounts. To find a fraction of a whole amount, we divide the number by the denominator and multiply the result by the numerator. So let's say we had a question asking us what is 4/6 of 30. So to work out this problem, just need to switch this off. So we have an example here which asks us to find what is 4/6 of 30. So following the steps we just talked about, we divide the number by the denominator and then multiply the result by the numerator. So 30 is a whole amount. We divide 30 by 6, which is 5. So 30 divided by 6, which is 5. And then from 5, we multiply this result by the numerator, which in this case is 4. So 5 times 4 equals 20, which gives us our final answer of 4/6 of 30, which is equal to 20. So just to recap, we have our whole amount, which is 30, and we divide this by the denominator, which is 6, which gives us 5. 30 divided by 6 is 5. And from our result here of 5, we then multiply this by our numerator, which is 4. So we do 5 times 4, which is equal to 20. So we have 4/6 of 30 is equal to 20. Okay, now we're going to look at equivalent fractions. So sometimes you may have a question which asks you to multiply fractions, add fractions, take away fractions, and sometimes the fractions may have large numbers or numbers which you are not used to working with, which is sometimes where it can be useful to know how to find equivalent fractions or to simplify fractions to make the numbers easier to use in order to carry out such operations on the fractions. So we have an example just to help you explain or understand what I mean in this case. So we have a fraction here of 12/18, and we want to find this fraction in its simplest form, or to find a fraction equivalent to 12/18. So to do this, our first step is to find the factors of 12 and 18. So the factors of 12 are any numbers which divide into 12 without any remainders. So 12, 1 goes into 12, 2 goes into 12, 3 goes into 12, 4 goes into 12, 6 goes into 12, and of course 12 itself is a factor. 12 divides into 12. And 18, 1, 2, 3, 6, 9, and 18. All these numbers divide into 18 without any remainders. So these are our factors of 12 and 18. Then, after finding the factors, we then look for the highest common factor. So what is the highest common factor? Well, the highest common factor is the highest number, which is both a factor of each of the numbers without leaving any remainders. So, if we look at our lists of factors for 12 and 18, we have 1, 2, 3, 4, 6, and 12. And for 18, we have 1, 2, 3, 6, 9, and 18. So when we look at these numbers, which number is the highest common factor of each of 12 and 18? Well, we can see our highest common factor, or HCF, is 6, because 6 is a common factor of both 12 and 18, i.e. it divides into 12. 6 divides both into 12 and into 18 without any remainders, and it is the highest number which divides into 12 and into 18. So our highest common factor, or our HCF, is 6. Okay, so then what we do is we say, okay, we now have our highest common factor, which is 6, and we divide both the numerator and the denominator by this highest common factor. So 12 divided by 6, which is 2, and 18 divided by 6 is 3. So we get an equivalent fraction of 2/3. So we then can say that 12 over 18 is equivalent to 2/3. We can also say that 12 over 18 in its simplest form is 2 over 3, or 2/3. And we can also find equivalent fractions using multiplication. So let's say we had 4 over 6, and we wanted to find another equivalent fraction by multiplying both the numerator and denominator by 4. So we will do 4 times 4, which is 16, and 6 times 4, which is 24. So we can then also say that 4 over 6 is equivalent to 16 over 24. So both these fractions are equal or equivalent to each other. Your turn. Let's have a go at a few questions. So we have to find the equivalent fractions either through simplification, division, or multiplication. So we've got 1 over 6 and 28 over 40. So you can pause the video and have a go, And then when you're done, we can work through each of the questions step by step. Okay, so I'm sure you've had a go at both of the questions. So let's work through them both one by one. So let's have a look at the first question. So we've got 1 over 6. And we can see here that this fraction is equal to some fraction with a denominator of 36. Now, if you remember from the previous slides, what do we have to do when we are looking for an equivalent fraction through in a case like this? We multiply. So we have to ask ourselves, how do we get from 6 to 36? Either by multiplying or dividing. We multiply. And what do we multiply by? 6. So from here to here, we multiply by 6. So if we remember also from equivalent fractions, anything you do to the bottom, you also have to do to the top. So if you multiply by a number in the denominator, you have to multiply by that same number in the numerator. So because here we are multiplying by 6 to give us 36, that also means we need to multiply by 6 here to give us our numerator. So 1 times 6 is 6. So our equivalent fraction here is 6 over 36. And in the second example, we have 28 over 40. Now, these numbers are quite large compared to the numbers in the first question. So the fraction we had here was 1 over 6, which is a fairly simple fraction to work with. But here, we see the numbers are quite large, so which indicates to me, which should indicate that we need to use division because we need to simplify this fraction into something easier to work with or into smaller numbers. So 28 and 40. So because we are going to use division to find an equivalent fraction, i.e. simplify the fraction, we need to find both. Firstly, find the factors of 28 and 40. So if we list them out, 28 and 40, so there's 1, 2, 4, 7, 14 and 28, and for 40 we have 1, 2, 4, 5, 8, 10, 20, and 40. Okay, so we now have listed all the factors of both 28 and 40. So now we look, okay, what is our highest common factor of both 28 and 40? So our highest common factor is a number that goes both into 28 and 40 with no remainders, and is also the highest factor which goes into both of those numbers. So if we look at our list, which number is our highest common factor? So 1 is a common factor, but it's not the highest. Then we have 2. Is there a higher number? Could it be 4? Okay. 7, 5, 14, 8, 10, 28, 20, 40. So if we have a real close look, we can see that 4 is our highest common factor, or HCF, because it goes into both 28 and 40 without any remainders, and it's a common factor, i.e. it is a factor of both 28 and 40. So what we then do is say, okay, now we have our highest common factor. We now divide both our numerator and denominator by 4 to give us the equivalent fraction to 28 over 40. So 28 divided by 4 is 7, and 40 divided by 4 is 10. So 28 over 40 is equivalent to 7 over 10, or 7/10. Okay, so we have a final example, which is another fraction. So we have 14 over 21. And again, the numbers are fairly large, which indicates we have to use division in this case. So our first step was to find the factors of 14 and 21. So we have 1, 2, 7, and 14. And for 21, we have 1, 21, 3, and 7. Now, if we look closely again, which number is our highest common factor? Of course, it would be 7, because 7 is the highest number, which goes both into 14 and 21 without any remainders, and it is also a common factor, so it goes both into 14 and 21. So we now have our common factor. Now we need to divide both our numerator and denominator by our highest common factor of 7. So 14 divided by 7 is 2, and 21 divided by 7 is 3. So our answer is 2 over 3, or 2/3. So just to recap, we first of all find our highest common factors for both 14 and 21, which we found to be 7, because 7 goes both into 14 and 21 without any remainders. And from there, we then use 7 to find our fraction in its simplest form. So we do 14 divided by 7 and 21 divided by 7, which gives us 2/3. So we can say that 14 over 21 in its simplest form is 2/3, and 2/3 is equivalent to 14 over 21. Both statements are valid or are correct. So that is how we would work out an example like this. So let's look at what we have done in this session. So we've looked at how to represent fractions. So that could be in a diagram. If we ask you to state what fraction is shaded in the diagram, then we would know, i.e. to look at how many parts are shaded and look at how many parts make up the whole. So both numerator and denominator need to be found from the diagram. And we then have looked at how to find fractions of whole amounts. So for example, if I asked you to find 3/4 of 24 or 3/8 of 40, these are finding fractions of whole amounts. Then, just briefly, or before, in the last few slides, we looked at equivalent fractions. So how would you find fractions in its simplest form, or finding fractions which are equivalent to one fraction using both multiplication and division? These are ways to find equivalent fractions. And that's our session done. So in the next session, in the next lesson, should I say, we will look at how to compare fractions and how to order fractions. So for example, you could have a list of fractions and I could ask you how to order these fractions from smallest to largest, or from a list of fractions, could you tell me which fraction is the largest or which is the smallest? That is what we'll be looking at in our next lesson. So thank you, and I hope it helps.